The chi-square goodness of fit test, or the goodness of fit test, it's also called the chi-square goodness of fit test because it uses the same test statistic and this formula. It's called a test statistic that we use for the chi-square test. And it looks like this. So it's the sum of the observed value. Okay, we have the expected value, and then we square that, and then we divide this on the expected value. So we use this formula for both tests. So a relevant question is, how and why are they different tests? For example, the chi-square test, we use that for seeing if two variables are dependent of each other. For example, choice of car, is that dependent on age group? Is the type of pet you have dependent on nationality, and so on. So dependence between variables. Now, what is the goodness of fit test for? It's for seeing if a dataset fits a particular distribution. So examples here could be IQ scores among students in a school. Does it fit with a normal distribution? And we know that IQ is distributed normally in a population. And we want to see if this also applies to this group. So in this case, it was to see if data fits with a normal distribution. Another example could be, do coin tosses fit binomial distribution? And we just to remind ourselves how these distributions look different. The normal distribution has this bell curve. The binomial distribution has these, it's like a histogram with these bars. Yeah. And the last one is what we call a uniform distribution where all the probabilities are equal. So for example, the third example here could be our dice throws consistent with a uniform distribution. For example, if you want to check if a die that you have is fair, you could throw it lots and lots of times, and you will get a certain amount of results for each value. And then you can use this goodness of fit test to see, okay, the results that you got, is that consistent with a uniform distribution? You're not going to get exactly the same as the expected values. That rarely happens. But is it close enough to be consistent with what you would expect? So that's the so typically these three distributions are the ones we would want to use a goodness of fit test against. So the main difference then is one of purpose. We can see that we use the chi-square test to check two variables, to check for dependence. The goodness of fit test is to see if a data set that we have fit a particular distribution. So the difference is mainly in purpose, and we also do the test a little differently, but they both involve this this formula up here. So that's why the goodness of fit test is also called the chi-square goodness of fit test. It's using this same formula as in the chi-square test.